We've been throwing around this word, vector, like everyone just knows it. Today we fix that with zero scary math. Because once you really get what a vector is, the whole idea of AI understanding meaning stops feeling mystical and starts feeling almost obvious. So take a breath. This is easier than it sounds. Welcome back to AI in 5. Let's rip the band-aid off. A vector is just a list of numbers. That's it. That's the whole definition. 3, 5, 1. That's a vector. The fancy word hides a very simple thing, an ordered list of numbers. The interesting part isn't the list itself, it's what we can make those numbers represent. And in AI, we make them represent meaning. Honestly, you use vectors all the time without flinching. A location on a map is just two numbers, latitude and longitude. That pair pins down one exact spot on Earth. That's a two-number vector. So when I say a piece of text becomes a vector, I just mean it becomes a set of coordinates, an address, that pins down its spot, not on a map of the world, but on a map of meaning. Now here's the only leap. Two numbers locate a point on a flat map. Three numbers locate a point in a room, left, right, forward, back, up, down. And there's no rule that stops at 3. AI embeddings use hundreds, sometimes thousands of numbers. You can't picture a 1,000-dimension space, and that's fine, neither can anyone. But the math works exactly the same as the map. More numbers just means a richer, more detailed address. So what do all those hundreds of numbers mean? Loosely, think of each one as a dial measuring some aspect of meaning. One dial might lean toward, is this about animals? Another, is this happy or sad? Another, formal or casual? No single dial is the meaning, but all of them together, the full list, pinpoints the idea precisely. Its meaning, spread across hundreds of tiny dials. And here's the subtle, beautiful part. What matters most isn't the exact numbers, it's the direction the vector points. Two sentences that mean the same thing point in nearly the same direction, even if they use totally different words. So the vector captures the gist, the underlying concept, not the surface wording. That's why rephrasing a question barely moves its vector. Same meaning, same direction. Let's contrast three things. A plain number, like 7, is just a quantity, no meaning. A word, like ocean, is full of meaning to us, but to a computer it's just opaque symbols it can't compute with. A vector is the bridge. It carries the meaning of the word, but in number form, so a machine can finally do math on it. That bridge is the whole reason embeddings exist. So how does a sentence actually get its vector? You hand it to the embedding model. The model, trained on mountains of text, reads the whole thing in context and outputs the list of numbers, the coordinates, that best place it on the map of meaning. You don't assign the numbers, and neither does a human. The model learned, from all that reading, where every idea belongs. So next time you hear vector, don't picture algebra homework. Picture an address for an idea, a spot on a vast map of meaning written as a list of numbers. The hundreds of dimensions sound intimidating, but they're just a very detailed address. That's genuinely all a vector is. So a vector is just a list of numbers that acts as an address for a meaning, and similar meanings get nearby addresses. Which leads to the obvious next question: how do we actually measure how close two of these addresses are? That's tomorrow. Vector similarity, the simple idea that powers every search. See you tomorrow on AI in 5.